All right, welcome to part 4 of solving LeetCode questions under 1 hour. So this time around, we're going to do the easy questions and continue from where we stopped on part 3. So go to LeetCode, click on algorithm, and then we'll filter by the easy and then sort it by the acceptance rate, right? So that's how we're doing right now. And then make sure there's no gap. Okay, there isn't. All right, so let's open like 10 problems, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. All right, so we have 10 problems. Cool. All right, and then we're gonna start the stopwatch. Oh no, sorry, not stopwatch. The timer. 1 hour, start. All right, let's go. Find center of a star graph. Okay, this might be a bit difficult, but we'll see. I think it's going to be easy. Let me see. There's an undirected star graph consists of n nodes labeled from 1 to n. A star graph is a graph where there's one center node, exactly n minus 1 edges, that connects the center node with every other node. Okay. You are given 2D integer array edges that reach. Okay, so this is the graph problem that has the start and end values, I would assume. So list of integers, yeah, okay. Indicate that there is an edge between nodes. Continuous star graph, okay. All right, so start and start. Okay, so this is an undirected graph, right? I think that's what it says. Okay, undirected graph. Okay. I'm assuming each node has a unique value then. All right. So the reason why this is an easy problem is because I would assume we just have to analyze like 3 nodes. I think how many inputs are there? And yeah, 3, right. See, okay. So we just analyze the first 3 values of those edges, and then we can just determine what it is, basically. With 2, that's too little information. With 3 is like, okay, what's the common number between these, right? So obviously in this case, we have 2, 2, 2, right? So that would be the common number. Or wait, is it just enough to check 2 then? Maybe it's enough to check just 2. We can just check this and then see the common number. Or yeah, maybe that's it. Yeah, I think that's it. Okay, so we just check the first 2 edges and then just check the common number and then return that number basically. So that's it. That's the idea. Okay, what's the easiest way to check that then? I guess we can do like a set, but I think that is just an overkill on the time estimate. So we'll just do this. E1 is the edge 1, so edges of 0, and E2 is the edges of the second one. And then if E2 of 0 is in E1, then basically we return the E2, right? So which means E2 is first number. And then else. So there's only 2 possibilities, right? E2 of 1. Okay, so I think this is just it. Let me just check that real quick. Yeah, okay. So basically what I did was, okay, so I'm just checking the E2, right? And then if this number is in E1, then, you know, it's obvious that this is the case. But if this number is in here, then it's not, right? So, I mean, that's the logic basically. So I'm pretty sure this is going to work. Yeah, we don't really care about the rest of the problem at all. Yeah, I'm surprised that mine is like 600. I don't think there is another approach than this one. Yeah, I'm not sure why this is like really slow. Oops, try reloading the page. Okay, let me just try again. Okay, it's still 600. Maybe this one is taking much time. So what I can do is if is equal E1 of 0, then return that, or like L wait, if that's not the case, then it can be the second one, right? Yeah, so elif e2 of 0 can be second one, then return. Wait, no. Let me think. So if it's not the first one, so okay, so if it is equal to the first one, then we just return that. But if it's not the first one, then we still return that, maybe? Is this it? We just check the first one? Maybe this is it. So no need to check the list if it's contains or not. Okay, let me see. So we're checking if this is equal to that. If it is, then return that. But if it's not, okay, so wait, we're checking if this is equal to this one. If it is, return that. If it's not, then, okay, so I think I should return the E1, the other one, like in here, right? So I think that's the case. Okay, so in here it did not work. Let me see. I think there should be like another OR statement. So we are checking if this is equal to this. Okay, yeah, it's not. So we're gonna return this one. Okay, yeah, this is wrong then. In this case, it's wrong. So in this case, we're checking that, or we can check if that is equal to that, then return E2. No. E1, E1 of 1, E2 of 0. Okay, so though both of these don't have the answer, right? So we have to return E1, 0 or E2, E2, 1. Okay, so this is definitely not correct. Okay, so I think there's can be like another condition then. If E2 of 0 is equal to E2 of 1, oh no, sorry, if E2 of 0 is E1, okay. So basically, if this is equal to that, then we can return oh wait, no, this is not it. Okay, so I think this is the case. Okay, if E2 of 1 is equal to E1 of 0, we can return E1 of 0. Okay, I think this is good. All right, let's just try that. Okay, it's still 600. Okay, I don't know what's going on, but I mean, I don't think there's anything faster than this. I mean, the in statement is basically this, right? Because we have only two numbers. So yeah, I think this is just maybe in the beginning of the problem we had many submissions like this. Let's just make sure the sensor is also connected to the nodes. Yeah, two edges must have come up with the sensor. Okay, yeah. Yeah, I don't think there's anything faster than this one. Okay, time complexity is obviously 01 because we're just checking, right? Space complexity, there's nothing. So it's still 01. We didn't create any variables. There's no like, we didn't check every node, right? So there's just 01. Okay, cool. All right, let's move on. The left-right difference, okay? Given a zero indexed integer array nums, find zero index integer array answer where the length is answer.length is num of length left right sum. Okay, this is kind of confusing. Let me see. In this array num, so could we have nums array and then find zero index integer answer. Okay, so we have to create an answer and that the length are the same. Okay, the answer is the left sum I, right sum I. Okay, I think it's just this minus sum of this one, right? So it's like 10 minus 12 to 15. Okay, that's not it. Okay, it says here the sum is the left elements to the left of index array. If there is no such element, left sum is 0. If is the sum of elements to the left of the index array. Okay, I guess if I take 0, there's no left here, so we're just gonna do this 0. Yeah, okay, here, and then in here we have 10 and then 11. Okay, so we exclude the number itself. Okay, I see. Gotcha. So if we are going here, that's like 14 minus 3, which is 9. And if you go here, then that's just this sum, right? 14, 22 minus 0. Yeah, okay. Gotcha. So I think obviously we can do brute force and solve this with n squared, right? So that's pretty bad solution. So what I would say is like calculate the cumulative sum first, and then just do these operations one by one at a time, like once. So there's no like inner loop. So we just create like a cumulative sum first. So I think there was a problem last week or something that we did cumulative sum, right? So it's just let's just do. I think it's called prefix sum also. Like let's just do prefix sum. Is that, and then s is equal to 0. So we have for n in nums pre-sum. Let's do n and then pre-sum dot append s. Okay, let's just print this and see if it's working. Let's just return the pre-sum for now. I know we know this is wrong, but just for returning like the list of numbers sake. Okay, so the pre-sum is 10, 14, 22, 25. Okay, that's good. So the idea is if we are in here, right, we know that this sum is equal to this minus that. So that's 15. But the left sum is just 0. So that is like 10 minus 10 or something like that. That's how we calculate it. But if we are here, then the right sum is, we know it's 11. So that's how do we determine that, right? That's 25 minus 14, that's 11. But in here, it's just 10, right? So, okay, so that's the idea. How do we do the sum? But on the left side, the sum is obviously just 14. Just take the left number. But in here, it's just 3, right? This minus that, okay? So let's do this. Answer is equal to that for I in range of length of pre-sum. So the left sum is equal to it's just the left index, right? So if I were here, it's just left. If I were here, it's just the left one, right? So what I can do is I guess pre-sum I minus 1, right? So that's the left sum. The right sum is the end minus the current one, right? So pre-sum minus 1, so that's the end, right? In Python, we can just access it by minus 1 minus pre-sum of I. So that's the current one. So the left sum, right sum. And then we could just answer dot append abs right sum minus left sum. It's just basically the equation, right? So return answer. But there is also one edge case where on the leftmost side, there's like we have to have 0, right? Because this doesn't exist. So I think we can do this. We can just start from 0, start from 1, and then we can do it because the first answer we can populate it, pre-populate it, right? So this is kind of like a fence post problem where we have to do edge cases first or last. But in this case, we're just gonna do it first. So the first answer is we just do this one, right? The sum of everything like here, which is 25 minus 10. So what we do is pre-sum minus 1 minus the current pre-sum of 0. Okay, we don't have to do this ABS in here because we know that pre-sum of this one. Oh, maybe it can be negative numbers, I guess. Can there be negative numbers? Okay, it cannot be. I think this just works. Let me just check. We don't have to do ABS in it because we know this is larger than that. Okay, I think this works. All right, cool. So the time complexity in this would be O of n, and the space complexity is obviously O of n too, because we created pre-sum array as well as the answer array, right? So those are both O(n). We don't have any nested loops, so it's just O(n). But yeah, if were doing nested loops, probably it's going to be around here because it's much slower, right? So Yeah, that's the problem, right? We are doing short on time, so let's just keep up the pace and hopefully we can make it. You are given a 0-index integer array nums and an integer k. Return integers that denote sum as elements of num whose corresponding indices have exactly k sets of bits in their binary representation. Oh, okay. Okay, it's the sets of bits is an integer of so the binary representation 21 is which has 3 sets of bits. Okay. Exactly k sets of bits in their binary representation. Sum of elements. Okay, let me see the example. What we're saying. Okay, so we have 13. This number, the binary representation of all the indices are so 0, 1, 2, 3, 4. Okay, so yeah, that's good. Yeah, indices 1, 2, 3, 1, 2, and 4 have key equals 1 sets of bits in their binary representation. Hence, the answer is okay. So basically, like this one, k equals 1 sets of bits. 1, no, sorry, not 0. Yeah, okay. This one, this one, and this one has number 1 in it, right? In terms of binary, and then we just sum those up basically. So that's the problem. Okay, I'm just gonna do this based on my knowledge. I'm pretty sure there is bit manipulation solution out there, right? But I'm not really good at bit manipulation, so I'm just gonna do this how I normally know. Which is just turn the number into binary strings and then do like a string manipulation problem, right? So that's how I would do it, essentially. Okay, so let's do that. For n in nums, and s is equal to bin of n, right? So this is how you turn a number into a binary string in Python. But I think we should do like this thing or something. Or do we have to? I don't think. Okay, so I don't think we have to. Because like if I do bin, then it just prints like b something, b xb or something. Oh yeah, it's here. See? So we don't want these things, right? But I mean, it doesn't really matter though if we want this or not. We can just leave it and then just count the number ones, right? Yeah. But oh yeah, sorry, this is not the numbers. It have to do the indices though. Enumerate. Yeah. So we have to convert it to the indices, not the numbers itself. Okay, let's do that. Okay, yeah, here. So the case that, so what we can do is, I think there's like a count function, right? I'm pretty sure. If s dot count of 1 is equal to k, then we just do the summation, right? Now let's just do answer. Answer plus n. And then answer. Okay, I think that's it. All right, cool. Yeah, this is it. So we just basically count the number of the string number, and then just if that's the case equal to k, then we just add it. So this definitely works, but it's not the cleanest solution. I don't. Okay, it's pretty good then. All right, cool. I mean, if it's performant enough, then we're just gonna leave it as this. So let's talk about the time complexity, right? And the time complexity wise, I'm pretty sure it's the same as the optimal solution, but it's just like theoretically it's the same, but we're practically obviously not, right? Because bit manipulation is so much faster. Okay, so the time complexity is, I want to say it's O of n. Space complexity is also, it's just O of 1. The reason why it's O of 1 is because the integers are set to maximum like 32 bits, right? So the S is like the largest it can be is like 32 length of string, but in Python it's like 34. So the maximum is just going to be 34, which is constant. So this is O of 1. But for time complexity, we're just enumerating it, right? And then we're converting it, which is also like 32 fixed time. And also counting it is also fixed because we're just searching maximum 32 string, right? So it's just like basically we can do 32 times n or something like that, but the 32 doesn't matter. So it's theoretically O of n. So that's why it's like, this solution is still like the same complexity as the bit manipulation problem. So yeah, let's just leave it at that. Cool. So we have finished 3 problems. We still have to finish 7 problem, and we're still behind. So given an integer and return the difference between the product of its digits and product of the sum of its digits. Okay. So it's pretty straightforward. So we have to calculate the product first, and then calculate the sum first, and then just, return the difference then. Product, okay, minus strength. Okay, cool. There is like a stupid way of solving this, right? So one of them is just basically turn it into a string and then do it that way. That definitely works, but it's not the most elegant solution, right? I think there should be a let's just do like 2 different functions. Digit sum, and then the number digit just say prod, digit prod. Okay, so we're just gonna call these 2 functions and then return digit prod n minus digit sum of n. Okay, and then we're just gonna complete these 2 functions basically. So we're not going to use string conversion. We're just going to use the numbers. And how do we do that? It's easy. So for the sum, let's just call it s, and then we're going to do while loop. So now if number is greater than 0, we're just going to keep on adding the last digit, right? So the last digit is what? It's that. And then we can get rid of the last digit. So how do we do that? We can do it so that we can just divide it by 10, right? So that's how we do it. But since this is like division problem, we can just do this. All right. And then return s, basically. So this is just gonna keep making the number 10 times less, right? And then just add that every while loop. So in here it's the same thing. Let's just copy it, and then it's basically the same code. Instead of adding it, we're just gonna multiply it, right? So, but I think there can be like edge case, but we'll see. I think this should work. What if the number is 0? Yeah, it's still gonna return 0. That's good. If it's 1, then yeah, it's still good. I think this is good. Let me see. Oh, it didn't work. Wait, what? Did I mess up? Prod minus sum, right? It's like the difference between product of its digits and the sum of its digits. Oh, is it like... Okay, so the prod is 624, digits is 9. Okay, I think I definitely messed up here. So prod, let me just print this out. What's the prod? It's 0. Oh, right, because it's like that. Yeah, okay, gotcha. I think I was sure there was an edge case. Yeah, we have to initialize it as 1, but also there should be a case where if number itself is equal to 0, then return 0, right? So this is like the edge case. Number other than 0, I think we can just go along with initializing as 1. Okay, so that's good. All right, cool. Let's submit that. All right, nice. We got the optimal solution then. Time complexity wise, this is like O of n. And space complexity wise is also O of n. Oh, no, sorry, not O of n. It's O of 1. It's both O of 1. It's because the number of digits is fixed, right? There's just no like upper limit that scales with the number. Because the number is 32 bits, and then if it's 32 bits, I think it's like the maximum is 2 billion, right? So 2 billion has like 10 digits, so it's a constant 10 loop here, and also there's constant 10 loop here. So there's no way that it's O of n scales with the number, so it's just constant operations. Okay, let's go to the next one. So we're barely making it on time. Now we should also keep the pace. A sentence is a list of words that is separated by a single space with no leading or trailing spaces. Okay, you are given an array of string sentences where each sentence represents a single sentence. Okay, And then return the maximum number of words that appear in a single sentence. Okay, I think that's pretty straightforward. Return the number of words, right? Return the maximum number of words. Yes. Okay, gotcha. All right, so let's just do max words and then define it as 0. And yeah, and then we just loop through each sentence in sentences. And then just count the number of spaces, right? Essentially. That's the easiest way to do it. Sentence dot count space. And if the count of spaces is, I'm pretty sure there's like an edge case, but max words, if that's greater than max words, then update the max words. I think I should store this in a variable. Space count. Space count. Return max words +1, I think. Right. But there's also an edge case of like empty sentences. I'm not sure if that's going to be the case. Okay, this definitely worked, but all the words everywhere, it does not have leading. Okay. Yeah, so I think it should have length is 1. It's okay. It has at least one word, so there's no like empty string in here. Okay, so I think this is good. So basically, like if there is if the space count is 1, then there's 2 words, right? So that's why I've added 1 in here at the end. So that's the word count, right? Okay. Also, I'm pretty sure you can do without the if statement with like using max keyword. So that might be the best. Let's see. Max words is equal to maximum of max words and then the sentence count. So I could just get rid of that. Okay, and just do this. Okay, yeah, this is much cleaner. So let's just use this solution. All right, so the time complexity is of n times m, basically. What that means is the m is the number of average length of each sentence, and n is the number of sentences. So that's why we're just doing 2 kind of loops, right? This because the count itself, it loops through the sentence and then counts number of spaces, right? So that's why. The space complexity it's just constant, right? So it's like O of 1, yeah. So we didn't create any new variables, so that's why. Okay, that's it. Decode XORed array. Okay, it's gonna be a tough one. Let me just check. Okay, so there's a hidden integer array R. Hidden, okay, there's a hidden integer array consists of n non-negative numbers, okay? It was encoded into another integer encoded array of length of n minus 1. Okay, so it's less by 1, such that encoded R XOR R plus 1. For example, this then encoded is that. Okay, so basically it's like every adjacent element is XORed. Okay, you are given an encoded array. You are also given an integer first, that is the first element of R, i.e. R0. Okay, return the original array. It can be proved that the answer exists and it's unique. Okay, so that's the encoder one. The array is that the first is encoded XOR XOR XOR. Okay. Okay, so what's the reverse of XOR then? We have to do that then. So essentially, like XOR is like this symbol, right? In the programming languages, it's gonna be like Q. So we know X is like the first, right? And we know Q is like the encoded of the first, right? So by this, we can just keep on going, iterating through, and then essentially find x, y. So how do we find y in here? What's the reverse of XOR? Is it and or? Okay, let me just try to figure that out. So 1 and 1 is definitely 1. But what is 6 and 4? Is it 4? Let me just check. 6 and 4. I'm just trying to guess what's the reverse. I think is it and? It might be and. Okay, so it's a 4. Okay, it might be and then. Because the or is definitely... wait, what's or? Is it just this? In Python? Maybe it might be. Okay, it's 6. Okay, yeah, definitely. So it's and then. So, okay, so the reverse of... So how do you find y? So y is like... y is equal to x and q then. Okay, so that's the code, I think. That's my guess, at least. So that's how you populate the answer. So let's just go with like answer is that, right? And then for and in encoded answer dot append, we do n and first, right? That's the key, but we have to update the first to this number, I think. Okay, so we store this number then. How do we store it? Let's just do the t temp value, and then we just do t, and then first is equal to t. All right. Okay, I think this should work. Let me just check. So we just have to keep updating the first. No, it's not. Wait, what? Output is that. Okay, so it did work for the 1 and 0, but let me just check the second case. Okay, it might not be the case. Maybe I just guessed it wrong because 4. Okay, so 6 and 4 is 4. And then there's the next one, 2 comes in. And then 2 and 4. Is it 0? Let me just check. Print 2 and 4. Maybe it is 0. Okay, yeah. So definitely it's not it. I guess we have to Google at this point, right? I don't want to think about like what's the reverse of XOR. Reverse of XOR. Version itself, the reverse bit XOR. Okay, so it's inverse function of XOR. Yeah, inverse. So you can get A or B back if you have one of the following variables. Okay, so I have A, where we want to get B. So B is equal to CA. Okay, it's just also an XOR symbol then. Okay, it's C XOR A then. So it's N XOR first then. Okay, in our case, it's N XOR first. Okay, so just do this and then I think that's it. Oh, it didn't work. Oh yeah. So this is like the edge case, right? So I have to add the first in here. Okay. Because that's the first number. And I keep on adding it. Okay, yeah, that's it. Easy. I definitely got help from Google for sure. Yeah, I'm pretty sure there's no way that this question is gonna ask on interview without this hint, right? I just can't imagine if there was someone that gave you this question without any hints like that, or at least like just give you a chance to write it down and calculate what's the inverse function of XOR, right? Then that person's a dick basically. It's like I would never ask this question in an interview. Yeah, I'm just basically trying to make that person fail. It's so cruel. Okay, so time complexity is just O of n. Space complexity is O of n also because we're returning array, right? Okay, That's it. And this is just bit manipulation operation. It takes constant amount of time because we have 32 bits, right? So yeah, that's it. All right, number of pairs. You are given two integer array nums1 and nums2. Okay, so both are integer arrays. Okay. Lengths of n and m. Okay, so they have different lengths. You are also given a positive integer k, so there's a third argument k. A pair I and j is called good if nums I is divisible by nums j times k. So I goes from n minus 1, this one goes from n minus 1. Okay, so it's just basically every number. Okay, return the total number of good pairs. Okay, I don't think there's like a trick to this question. I think we just have to do like force nested loop and then find this condition and then add it. So let's just do answer 0 for I in range of do I have to do range? Yeah, I don't think we should. Yeah, I think this is fine. Okay, so we just do n in nums1 for m in nums2. I think we can just do this instead of doing indices. Yeah, I'm pretty sure. If nums of y is divisible by, okay, so we have to do m times k divisible by n, right? Which not return answer plus minus 1. And then as I think this is it. Oh, is it not? Output is 6, expected 2. Wait, what? Okay, let me think. K is 3. So this is good. We have 5, 5. But in here, J is from 0 to m minus 1. Yeah. Nums good is divisible by that. It's a good pair. Let me just print like n and m here. So yeah, we definitely have 6. Is there any other condition? The lengths of n is given the positive integer k. Good pair if divisible by that. Return the total number of good pairs. Yeah. Expected 2. Okay, so why is there 2 in here? There are 2 good pairs, 3, 0 and 3, 1. Okay, why? 3. So why isn't that this one then? Okay, so 2, this one, and then... Okay, wait. This is number 1 here. Yeah, and then 2. Yeah, so... 2 times 3 is 6, and 6 is divisible by 1. Right? So why is I'm just trying to understand where did I make a mistake. 3, 0. This is corresponding to the index. So 0, 1, 2, 3, it's that, and 0 is like that. Or is it the other way around? Am I not doing it right? Like that? Okay, it's the other way around. Okay, cool. I guess one optimization that I can see is definitely multiply each element of nums2 by k, right? But it doesn't really matter, I would say. And just do this without that. Yeah, these can be random numbers, but I mean, it's not gonna matter that much, but I believe we can help a bit. I would say, okay, that's fine. We'll just leave it at this, but definitely there's like one small optimization is where we multiply each number of nums2 by k, and then it will slightly improve. But theoretically, like in terms of big O complexity, it's not gonna matter much. So we have n times m, right? The number of elements, and the space complexity is just O of 1. So there's no way getting around it because it's just random numbers, right? So yeah, this is the maximum that we can get. All right, cool. We have 3 problems and 20 minutes left, so we're doing good. Reverse prefix of word. So it says given 0 index string word. Okay, and the character cha, reverse the segment of word that starts at index 0 and ends at the index of the first occurrence of cha inclusive. Okay, if the characters, yeah, I think that makes sense. So we have d, so it's d, and then we just reverse. Oh, it's up until d then. Okay, so we just reverse everything here and then I just attach it there. Okay, cool. All right, that makes sense. I'm pretty sure there's like a function that can give me the index of the first occurrence. So words dot, I think it's find return. Let me just see if this is correct. Okay, yeah, it does return like the first index. Okay, so it's 0, 1, 2, 3, right? So yeah, it just returns d. Even if it's not, it's really easy to implement this find function, right? Super easy. Just do like a single loop. All right, let's just use this for.find function. Not for. Let me just do it here. Just do like index. So that's the first index. And then what do I do is like word up until the index, right? So that's the first segment. And then I do reverse, right? So this is how you reverse in Python. There's like a reversed function, I believe, I think. You can do that too, but I think this is +1, I believe, because we want to include the index, okay? And then what we can do is index +1 and then do this. Let's just see if this works. Yeah, okay, that's it. So basically this function, this like slicing is like reversing the string. You can also create a method for that, but I think it's just really straightforward to reverse a string, right? It's pretty easy. And if I do this is until the index, right? So we want to capture the index. So that's why I did +1. And also this is like slicing, including +1. So that's why I did it. Yeah, there's just no way of getting around this, to optimize this further. So this is it. I think also, I think I can do reverse it or something. Does that work? Let me just see. Maybe it doesn't work. Yeah. Unsupported type error. I think there should be like dot, or maybe it's dot reverse or something. I forgot. Yeah, it doesn't have any attribute reverse. There is something that you can reverse in Python. I forgot which one is it, but I mean, I typically just use this function to reverse it. It's kind of weird to memorize it, but still, I just memorize it as like 2 colon -1. That's it. All right. So in terms of time complexity is O of n, right? And then space complexity is, yeah, we'll just say O of n because, we're just returning the O n is, by the way, number of characters, right? So the space complexity is also returning the same length of the n, right? So that's why it's O of n. And in here, obviously, this function is like O of n because we're gonna search each index, right? And then this reverse is also O of n, and then concatenating it is just O of n too. So, yeah, there's no like nested loop or anything like that. So it's just O of n. Right. What's this? Split a string into balanced strings. Okay, what does that mean? Balanced strings are those who have equal number of L and R characters. Okay. Given a balanced string S, split into some number of substrings such that each substring is balanced. What? S can be split into RL, RR, LL, RL. Each substring contains the same number of L and R. Okay. S can be split into RL. Each substring contains same number of LNRs. Okay, note that. I'm just very confused on the substring part. Okay, so RRLL is this part, right? Oh, I see. Substring meaning like if I cut this, then I can cut it here, then cut it here, and cut it here. Each subsequent is the same number of LNR. Yeah, okay. Since those have an equal given the balance string, split into some number of substrings such that each balance return the maximum number of balance strings. Okay. Gotcha. I see. So I think it's pretty straightforward. What I can do is like, okay, so assign like R as +1, right? And then L is like -1. So basically from left to right, I just keep adding 1 whenever I see R, and I subtract 1 whenever I see L. And then every time it occurs to 0, then that means it's balanced, right? So that means there's like a substring there. And then it's kind of like a greedy problem where if I see 0, that's a substring, so we just put that into a segment. And then every time I see 0, that's going to be the maximum, right? So each time it hits a balance, then we just instantly put it into a segment. So okay, so we just do like score, I guess. So score is 0, and then for C in S, if C is equal to R, I just do score +1, right? And then else, I just do score -1, okay? And every time there's a score is 0, then I do and I increase the answer by 1, basically. Answer is the number of maximum segments, right? So the maximum segments is like whenever there is a score of 0. So answer is equal 1, and then just return it, is basically. All right, cool. Yeah, that's basically it. It's kind of like a greedy problem where you have to recognize this, and yeah, easy. Cool. Time complexity is O of n because the n is the number of characters, right? And then the space complexity is just O of 1. Yeah, there's just no storage that we did. Yeah, n is the number of characters, so that's why. Cool. Yeah, this was a pretty good problem, I would say. Okay, so the last problem. So we have 13 minutes left. I think we're going to make it this time, unlike last time. You are given a positive number, integer num, because it's exactly 4 digits, okay? Split num into 2 new integers, new1 and new2, by using digits found in num. Leading zeros are allowed in new1 and new2, and all the digits found num must be used, okay? For example, given this number, you have following digits 2, 9, 3. Some possible pairs are, okay, we can, split it that way. Yeah. Return the minimum possible sum of new1 and new2. Okay. It's a kind of like a really tricky problem. Not tricky, it's like kind of gruesome problem. Well, not gruesome, I guess. It's kind of like, what a pain, right? If I see this in the interview, I would be like, oh, what a pain. Because obviously, like, we can do let me think. If I split it by 1 and 3, that means it's going to be minimum 100. So that's bad. But if I split it into like, maybe if I sort the digits, right? And then pick like the smallest 2 digits on num1 and num2, and then pick the rest. Is that gonna do it? Let me think. Maybe that's the optimal problem. But I mean, even if you can't get the optimal solution, I would just, do some brute forcing and then just come up with that, because there's just so small number of possibilities that you can do, right? You can get like a limited number of pairs into 1, 3 or 2, 2. Well, 1, 3 is like you can have 4 occurrences, not 4 occurrences. I mean 4 possibilities. But for 2, 2, it's like 1, 2, 3, 4, 5, 6. Yeah, 6. So okay, so we just have to check 9 possibilities, and that's it. I think. Yeah. 9 possibilities, but there's also the reversing digits and stuff like that. So I guess it's kind of a pain to check all of the possibilities. But definitely, I think one solution is like sort the digits and pick the digits based on that. Pick the num1 and num2 based on the sorted digits. Okay, let's just try that. Digits is should I do it as a loop? I guess I can do it as a loop. I was just trying to do something like num that's the first digit. Num 100, and then that would be the second to last digit, right? Then 1000, and then do 100. That would be the third digit. And then what I can do is like num divided by 1000. That's going to be the last digit. So let me just check if this is right. Turn 0. Okay, 2392. Okay, so we got all the digits because it is exactly 4, right? You can do this in a loop, but I just chose not to. Because we're just going to use the fact that we have 4 digits, right? So let's just do like digits dot sort and then print out the digits for now. Oops. And then it's going to be like 2239, right? Okay, yeah. So now what I'm thinking is like, okay, just return like the sum of this one and that one and this one and that one, right? So is that gonna give me the, yeah, I think that should give me the best answer, right? So let's see. If I do this and that and this and that, yeah, let's just try that. I'm pretty sure it's gonna give me the right answer, but we'll see if it's not. Okay. Let's just call it D for simplicity because I don't want to keep typing digits. D, okay. D of 0 times 10 plus D of 2. That's going to be the first number. Then the second number is D of 1 times 10 plus D of 3. Okay, cool. Let's just do that. Yeah, easy. Oh yeah, delete the print, by the way, because printing, increased the time a lot. So let's just submit again. I guess it doesn't matter in this case because we have too few test cases, it seems like. All right, so we have time complexity is just O of 1, and space complexity is also O of 1. Because we just have like 4 elements, right? Sorting 4 elements is nothing. And also adding this, it's nothing. And then we didn't store any thing that is scalable to numbers. So we're just storing the 4 numbers, which is nothing. Yeah, so that's why it's like 1. All right, cool. So we have finished everything. We have still 7 minutes left. All right, let's stop the stopwatch and then review if we missed anything. Let's just try to go to our profile and see if we have 39 problems. What the hell? Did I miss a problem? Okay, I think I missed a problem. Then I have to resume the stopwatch. How can I miss it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which problem did I miss? Okay, so let's just refresh and maybe there's a gap. Maybe I didn't submit the problem. Reverse prefix of a word. Okay, so I think I didn't submit this. Okay, let's submit. Okay, there we go. Now we should have 40, right? Okay, yeah, 40 solved. That's good. All right. Yeah, that was the 4th part of our LeetCode challenge. And yeah, we'll do 10 more next then. And yeah, if you have any questions, please let me know. Otherwise, I'll see you around.